Quantum physics, it sounds complicated, right? Like a subject reserved for scientists in white lab coats working in secretive labs, like something out of Star Trek or a sci-fi movie. But what if I told you it's all around us? It's not just in the realm of science fiction, it's the science of the very, very small, the atoms and the particles within them. These tiny building blocks make up everything we see and touch. Imagine a tiny, invisible world. A world so small it's beyond the reach of our naked eyes. In this world, things don't behave like the world we see. They follow different rules, almost like a parallel universe. Here, things aren't so clear. The lines between reality and possibility blur. It's more like rolling a die. Each roll is a mystery until it lands. You know you'll get a number, but you can't be sure which one. This randomness is a key feature. That's the heart of quantum physics, uncertainty. It's a world where probabilities rule. This uncertainty isn't because we don't have good enough instruments. It's not a limitation of our technology. It's built into the very fabric of the universe. It's a fundamental aspect of how nature operates. It's a fundamental fuzziness that governs how these tiny particles behave. This fuzziness is what makes quantum physics so fascinating. But don't worry, we'll break it down together. We'll make sense of this complex world. We'll explore this strange and wonderful world, a world full of surprises and mysteries. Get ready to see the universe with new eyes. Prepare to embark on a journey into the quantum realm. We're used to the world working a certain way. We wake up, go about our day, and everything seems to follow a predictable pattern. Drop an apple, it falls, gravity pulls it down, and it lands on the ground. Throw a ball, it follows a predictable path. The arc it makes is something we can calculate and anticipate. That's classical physics, the physics of Isaac Newton. It's the framework that explains the motion of everyday objects. It's neat, it's orderly, and it works great for big stuff. From the motion of planets to the trajectory of a rocket, classical physics has it covered. But zoom into the world of atoms and particles, and things get weird. Suddenly, the rules change. The predictable world we know starts to behave unpredictably. Our apple, now a tiny particle, doesn't fall in a straight line. Instead, it behaves in ways that defy our everyday experiences. It's more like a wave spreading out, existing in multiple states at once. This duality is at the heart of quantum mechanics. This is where classical physics throws up its hands and quantum physics steps in. The old rules no longer apply, and new, strange principles take over. It's like classical physics is a map of a city, showing us streets and buildings. It gives us a broad understanding of the layout. Quantum physics is like zooming in on a single brick in that city, revealing the atoms and the strange rules they follow. It's a deeper dive into the fundamental nature of reality. Let's say you're playing Dungeons and Dragons. You roll a 20-sided die. Until it lands, the outcome exists in a state of possibility. It be a critical hit, a fumble, or anything in between. In quantum physics, particles behave similarly. They exist in a state of superposition, like that die spinning in the air. They're not in one definite state until we measure them. It's like our observation forces the die to finally land on a number. Imagine a magical sword in your game. It can be in two places at once, your hand its sheath. Only when you observe it does it choose a location. Sounds crazy? That's quantum superposition. Section 4. Quantum in your pocket. From lasers to smartphones, quantum physics might seem like something out of a science fiction novel, but it's already shaping our daily lives. Those lasers scanning groceries at the checkout? Quantum physics. The transistors powering your smartphone? Quantum physics again. Quantum mechanics is the backbone of many technologies we take for granted. Medical imaging, LED lights, even the internet, all rely on the principles of quantum mechanics. Section 5. The Quantum Frontier. A universe of possibilities. We've only just scratched the surface of quantum physics. This field is still in its infancy, yet it holds the promise of transforming our understanding of the universe. It's a vast, mysterious realm with the potential to revolutionize our world. The possibilities are as endless as the stars in the night sky. Quantum computers, if we can build them, could solve problems in minutes that would take classical computers billions of years. These machines could unlock new levels of efficiency and problem-solving capabilities. Imagine teleporting objects like in Star Trek. This isn't just science fiction, it's a potential reality that quantum physics could bring to life, or developing new materials with unimaginable properties. These materials could revolutionize industries, from healthcare to construction, making the impossible possible. Quantum physics makes even the impossible seem within reach. It challenges our understanding and pushes the boundaries of what we believe is achievable. It's a reminder that the universe is full of surprises, waiting for us to unlock them. Each discovery opens a new door to possibilities we never imagined. So, the next time someone mentions quantum physics, don't be intimidated. Remember the die, the magical sword, and the endless potential they represent, and the power hidden within your smartphone. These everyday devices are just the beginning of what quantum technology can achieve. It's a reminder that even in the face of uncertainty, the universe is a wondrous and exciting place to explore. The journey into the quantum realm is just beginning, and the future holds endless possibilities.